Hello ladies and gentlemen, thank you for watching our video, taking the time out of your weekend to take care of this. I know it's one of many things you'd probably rather not be doing this weekend, but if we take these 10 minutes now, it's going to help make these last 8 days of school really swing by for us. So I appreciate it, and I'll try and make it as quick and painless as possible. Today we're going to extend on what we did on our last class, simplifying radicals, and now we're going to take it into simplifying variables. So just as before, take your notes, ask questions, rewatch if you need to, but most importantly, take notes and jot down those questions so that you can bring those with you to class on Friday, or you can bring them with you to class on Tuesday, and we can discuss them as a whole group and everybody learn from each other. So let's get into it. We've already talked about how we're going to take something simple like the square root of 81 and turn that into 9, because 81 is a perfect square, so when we take the square root of it, it becomes 9. We also talked about how if we had something like the square root of 104, which is not a perfect square, but we can still simplify that by pulling out the perfect square factors of 104 and simplifying it 2 times the square root of 26. What we're adding on today is we're going to have something like 18a to the 5th power, and we're taking the square root of that. So what that ends up coming out to is 3a squared times the square root of 2a. And again, I don't expect that to make sense now, but just so you understand what we're doing, that's the kind of problem we're looking at. And all that's possible because of this simple fact, which is that if we have the square root of x squared, that's x. Okay, let me say that again without that weird pause. The square root of x squared is x. Okay, it may seem like a simple statement, but it's critical to everything that we're going to be doing today, which is solving radical expressions involving variables. Okay, so we will do some examples, start kind of building our way up from what we did into what we're going to be doing new today. So, quick review here. Last class, we talked about how to take 180, and we figured out that 180 was 36 times 5. And so we split it up into having the square root of 36 times the square root of 5. And since we know the square root of 36 is a perfect square, we can simplify that to just 6. Square root of 5 can't be simplified, so we end up ultimately with 6 times the square root of 5. And we know that if we take the square root of 180, and if we take 6 times the square root of 5, they're going to come out to be the exact same thing. Okay, we're doing the same thing with that at its most basic level, but we're going to extend this to include variables. And this little line down here is really important. The same rules that worked with numbers before is going to be the same exact thing that works with the coefficients of our numbers now. Okay, so don't forget this stuff. Don't let yourself lose this stuff. Don't distract yourself and think you have to do this part differently. When you see a number, this is how you simplify it if it's under a square root sign. Nothing changes. Okay, let's get to the new stuff. At our most basic level, we are looking at a variable squared, in this case x. So to simplify it, it just becomes plain old x. Okay, remember, a perfect square means that you have a number that would multiply by itself to get to that number. So if the number is x squared, then x times x is what we're ultimately going to end up with. Okay, so that means that the square root of x squared is x. Now, if we have something like the square root of x cubed, or x to the 3rd power, well, then we have to simplify it just like we did before, looking for the perfect square factors. But this is going to be a little different from what we're used to. When we're thinking of factors, it's two numbers that multiply together to get, in this case, x cubed. So two numbers that would multiply together to get x cubed are x squared and x, right? If we think back to chapter 7, if we're adding the exponents here, 2 plus 1 is 3. So the square root of x squared times the square root of x equals the square root of x cubed. That's what we're looking for. But the good news is the square root of x squared, we've already talked about. What is the square root of x squared? It's just x. And so we can simplify this down to x times the square root of x. And this process that we see right here, okay, taking a variable that's to some power, splitting it up into its perfect square powers and its non-perfect square powers, and then simplifying the perfect square powers, this right here is the meat of what we are doing in this chapter. This is the new stuff. So if this doesn't make sense, if you can't figure out where we're going here, this is the video, or this is a part in the video you might want to rewatch. This is the part you're going to want to take some notes on. This is the part you want to ask questions on, because this basic idea that I just showed you is the meat and potatoes of what we're doing. Now, as with every meat and potatoes deal or dinner, it's always nice to have a little bit of extra on the side. So let's go one step further. What if I have the square root of x to the fourth power? Okay, ask yourself, how many perfect square factors do you think I'm going to have, and what are they going to look like? Take a moment to think about that. Okay, we should end up with 2 perfect square factors, because x squared times x squared is x to the fourth, right? 2 plus 2 is 4. So that means the square root of x squared times the square root of x squared is the square root of x to the fourth. So that's how we're going to do our split. And what's nice about this is we know the square root of x squared is x. So both times we end up with x times x, 1 for each of our 2 factors. And what does x times x equal but x squared? So the square root of x to the fourth is x squared. How about that? Now, let's look at a real problem like what we're going to see. Okay, here's what we start off with. Okay, the square root of 90 x squared y cubed z to the fourth. Now, the first thing we're going to do is we're going to split this up into each one of these separate factors. So we have the square root of 90 times the square root of x squared times the square root of y cubed times the square root of z to the fourth. Okay, split each one of those up. Start off by doing that. Then we simplify each one of these square roots. So how do we simplify the square root of 90? Same way we did before. We split it up into its perfect square factor, 9 and 10, and we know now that we're going to be able to come back and simplify that later. Then we look at the x squared term and we think about, okay, well, how many perfect squares for x squared could we pull out? And x squared is already a perfect square, so we're just going to be able to leave that one as it is. Then we look at y cubed, and y cubed is also y squared times y. So we'll split that up into the square root of y squared times the square root of y. And then z to the fourth is going to be z squared times z squared. Okay, this is another good time to pause the video if you need to and really work through how I got each one of these new factors. Okay, I'm taking what's up here and I'm simplifying it, I'm breaking it down into its perfect square factors. Okay, x squared stays as x squared, y cubed is y squared times y, z to the fourth is z squared times z squared. Okay, make sure you get this point. If you can get to this point, the rest is relatively easy, because now I just have to simplify each perfect square. So square root of 9 becomes 3, and since there's nothing else I can do with the square root of 10, that just stays as the square root of 10. You'll see why it's spaced like that in a moment. The square root of x squared is just x, so that's going to come up front. Nothing left after the x's. Y squared becomes y, or excuse me, the square root of y squared becomes y, and that leaves me with the square root of y there. And then each of my square roots of z squared become z and z again. And ultimately then, I take all this, 3 times x times y times z, that simplifies to 3xyz squared, and it's z squared because I got 2 z's. And then 10 times y is 10y, those go under the same radical, and just like that, I've got my solution. Now, I am not going to lie to you guys and say that this is just as easy as what we were doing before. This is definitely a good deal more work to do, but we are still doing the same thing. It's just trickier with these variables. So again, look at this, work through this again, try it again on your own. We're going to try another example separate after this, but before you move forward, take some time to really kind of calibrate yourself and see how much this makes sense. Okay, now here is another example, the square root of 32a squared b to the fourth c to the fifth, and I want you to stop the video and I want you to try this on a sheet of paper on your own. Okay, just try it. Feel free to do it wrong. Okay, it's certainly okay to make a mistake this first time through with it, but I want you to try it on your own, and then you'll come back to the video and I'll walk you through it fairly quickly, but still step by step. Okay, so first thing I do, split everything up into the variables. Okay, so square root of 32, square root of a squared, square root of b to the fourth, square root of c to the fifth. Then I go through and I split everything up into their perfect square factors. So square root of 32 becomes 16 and 2, 16 being my perfect square. A squared is already a perfect squared, so it stays there. B to the fourth has b squared and b squared. C to the fifth has c squared, and then another c after. So what I'm hoping you guys are starting to realize is we kind of like pull these out in pairs, right? How many twos are there here? There's 1, 2. How many twos are there? There's 1, 2 twos. Here there's 2 twos and a 1 left over. That's kind of how I think about this. But I split everything up into the perfect squares. Then I go through and simplify each perfect square. So the 16 is going to become a 4. The a squared will become an a. Each of the b squareds will become a b, and each of the c squareds will become a c. So I'll have this, okay, 16 to 4, a to a, b to b, b to b, c to c, c to c. And the 2, nothing can simplify there, and the c, nothing can simplify there, so they stay inside the square root sign. And then ultimately I combine all my like terms, and lo and behold, there's an error. Tell me what the error is. Did you catch it? Okay, I forgot to change the x, y, and z. So it should be a b squared c squared, not x, y, z. I'll pull up a Zaption right now so you guys can see the correct answer written out. Okay, one last thing, and it looks trickier than it is, but we do have to divide radicals as well. But if you'll remember, multiplying radicals meant you just put whatever was inside the radicals into one radical sign. Now it's going to do the same way, but we're going to work backwards a lot of times too. So here we have basically a fraction, but it's division inside the radical sign, and we're going to split that up. And the reason we want to split it up is because square root of 35, there's nothing we can really do with that, but what's the square root of 16? Yeah, the square root of 16 is 4. So now we have the square root of 35 over 4. And that's much neater to look at than this kind of ugly looking radical with this tall radical sign and a fraction on the inside. Yeah, we don't want to do with that. So basically what I'm saying here is if you look at your radical, and you will have problems like this, and you see there's a perfect square. So 16 is obviously a perfect square. Well, if we see that, then we know we want to do this kind of split up and simplify the top or the bottom if at all possible. Technically speaking, you don't want a radical in the bottom, so I'm going to give you a hint. Look in the bottom. Verify that that's not a perfect square before you just leave something alone. Now, in that same vein, we might also have it where it is split up, but we can simplify it if we put it together. So instead of having the square root of 60 over the square root of 15, we can rewrite that as the square root of 60 over 15. Now, if you know how many minutes are in an hour, you know that 60 divided by 15 is 4, and the square root of 4 is 2. So we can even use this rule backwards and still have it help us simplify. So nuts and bolts of it is you're going to have some problems that have you dealing with division of radicals. The ultimate goal for all those problems is going to be for you to be able to simplify. So you've just got to find those perfect squares, in particular on the denominator, and see how you can use this rule to help you manipulate the expression and simplify it. All right, that's it. That's it. All right, I'm not going to go over any more examples. If you need to see these again, go back. I've got the recap slide coming up after this, but if you have questions, jot them down, shoot me an email. Have a fantastic weekend. Looking forward to seeing you guys next class.